Okay, RJ, thank you so much for joining me.
Thanks for having me.
Yeah, we're excited to have you.
Yeah.
So my icebreaker question, I asked this of Kyle Vogt yesterday, and it went down well. So I would be curious to know, as a child, if you take us back to baby or young RJ, like what was your first faux business or first revenue as a child that can't come from your parents?
My first idea for business was a metal polishing business. And I grew up, I loved to build things, and so I had a little workshop and a little polishing wheel. I'd walk around my neighborhood and collect people's metal things and polish them. And I even made business cards.
Yeah? Okay.
Yeah. So the business card said my name, and then it said, I polish metal.
How long did that last for?
Like probably 2 years.
Okay, yeah, that's a good business.
Yeah. I had some recurring
Probably
customers.
better than like delivering newspapers or something.
Yeah, something like that.
Yeah, awesome. So you, I think, have a super interesting background. I think more than anyone else, it seems like you've had this kind of singular life focus on building a car company. I'd love to hear a bit about the story around sort of how you came up with the idea for Rivian, why you wanted to start a car company, and then how that sort of affected your choice of college and things like that.
Yeah, I mean, I grew up a massive car enthusiast, and as I said, I've always loved to build things, and very good with my hands and putting things together. And so, I mean, not far after my metal polishing business, I realized I wanted to start a car business, which is a natural leap.
One step up, yeah.
Yeah.
Could have gone to car polishing first.
Yeah, so since being maybe 10 or 11, I knew I wanted to build a car company. I had no idea what that meant. Of course, wildly underestimated the complexity in building something like this. But then subsequently did a lot of things to set myself up for it. So I worked as a machinist, and then I worked in a car restoration shop, working on classic Porsches and Volkswagens, which was a lot of fun, like old Porsche 356s for any of the car fans out there. Then went to school for mechanical engineering, and I knew I had the hypothesis, which was completely accurate, that I would need a ton of capital. I didn't have any capital, and so I knew I wanted to start the company when I was young. And so I decided to do a PhD as a mechanism to demonstrate credibility of some sort as a pathway to try to raise capital.
Right.
And so that was my hypothesis. If I do a PhD, somebody's more likely to...
They might give me money.
Yeah, invest money in this young guy trying to start a car company. So I did a PhD.
Maybe the skills would be helpful as well, but...
Yeah, maybe.
Yeah.
But amazingly, that sort of worked out. A lot of the early initial capital and the seed financing for the company came either through, ironically, my background in working on classic cars,
right.
Or through relationships at MIT.
Awesome. So you came, and so you came straight out of the PhD program, and you're like, anything in between there, or you?
So I did as a mechanical engineer, you build things as part of your thesis. So I built a very complex future powertrain system, and I was sponsored by a few different car companies. And so I was doing a lot of work with different car companies. And there was a moment where I thought, maybe I should go try working at one of these car companies. And it was a very brief moment because I realized just the scale and the history of these legacy businesses makes it really hard to drive first principles innovation where you're willing to change everything. And so, the day after I graduated, I incorporated Rivian.
Yeah. That's
like
incredible.
Literally the day after.
Yeah.
Like
Okay.
the next business day was the first day of Rivian. Yeah.
And did you? It wasn't called Rivian actually. I think originally, right? There was.
Yeah, I didn't know. One of the things in building, especially a consumer-facing brand, is you have all these things that need to come together that are not in any way deterministic. So, brand, the tonality of the company, the types of decisions you make that aren't at all quantitative or objective. They're highly subjective.
Maybe not things you're thinking about when
you're doing a PhD.
The day after your PhD.
Yeah, and so one of those is, what do you call a company that's going to build vehicles that are going to evoke an emotional response? And so we went through a couple of different names before we arrived at Rivian, and I'm really happy with Rivian, but we made up the word. It's a phonetically nice sounding word that didn't have any meaning in any language, which was the objective. But and then built our brand story around that.
And so that's and so how as a the day after your PhD program, I guess how did that go? Raising money, just kind of you hit.
It was really hard. Yeah. Imagine. Now I can say it in hindsight, and it looks even harder. But to start a car company, you need.
I mean, this was what
2009.
9. Okay.
Yeah. So you need if you're being intellectually honest, you need many billions of dollars. You need thousands of engineers. You need a manufacturing plant that's millions of square feet, filled with thousands of employees. This is if you want to build a car at scale.
This is like post-financial crisis as well, I guess.
Hundreds of suppliers.
Going bankrupt left, right, and center.
And so we had none of those things. You don't have the capital to develop the tech. You don't have the tech to raise the capital.
Yeah.
And so the early, the first investor pitches were laughably bad. You'd go in and the discussion would start with some version of, well, tell me about the business. Well, it's a car company. What's your product? Well, we still have to define that. That's why we need the money. Well, you must have some tech. Well, no, that's why we need the money. And you'd go through this loop of everything goes back to, well, without the capital, you're really not going to develop the tech.
Yeah.
And you sort of and by the end of it, you're thinking to yourself, boy, I wouldn't invest in this thing either. This is one in a billion shot, and you have to go lick your wounds and say, okay, how am I going to go sell the idea again? And so the first few $1 million of capital that you raise you're not really working on the real solution. You're working on approximations of the solution or approximations of a subset of the product to try to show some semblance of credibility and capability that would invite more capital to come in. And that took many years. It took many years for us to go from laboratory scale ideas to actually developing full-fledged prototypes. And it's part of the challenge of a lot of hardware companies, but in particular a car company, is your first dollar of real revenue will take many billions of dollars of investment. And if you had those billions of dollars investment and a team of, let's say, 4,000 or 5,000 engineers, and let's say 200 to 300 suppliers that are going to provide the things that you don't vertically integrate and make yourself, like let's say tires or seats, it would still take you 4 years from the starting point. So it's just a really hard problem. And so I used to joke all the time, it'd be a lot easier to start a company like this if you started with a lot of money. If you started with $1 billion, it'd be a lot easier.
A pile of money and a team that already knows what they're doing.
Yeah.
I mean, I imagine even convincing the first couple people to join, they probably thought you're crazy too.
Yeah, and of the first 10 employees, 8 are still with the company. And so, which is really cool because we remember, you think back, and now I know these, they've been at Rivian for 15 years. I know them really well. And I remember the first person that we hired that wasn't just somebody who had just graduated, but actually was leaving a job, had kids, and they showed up to the office, and he brought his wife. He's now, we've been working together since the beginning. His kids are grown. He brought his kids in. I'm like, holy shit, he's got kids. We can't screw this up.
Yeah, it's depending on.
We better make this work. Then that started to compound. So
he's the reason for Rivian's success.
Yeah, that was the core motivation.
Yeah, good.
Make sure Brian's kids
jump in a
can
hole
eat.
and dig your way out. Yeah.
Yeah.
Awesome. Well, this is, it's an incredible achievement. I mean, now in the Bay Area, I don't know about you guys, I'm seeing Rivians everywhere. So it's incredible that you're able to go over 15 years from, nothing, a PhD, I guess, up to Rivians driving around everywhere. This is a robotics conference though, so we're gonna talk a bit about autonomy.
Love to.
I'm curious, I guess, when getting a car company off the ground is, a million different things I'm sure you're focusing on. When did kind of autonomy come into your sights? When did you start thinking about that?
Well, we took a few decisions early on that were, in the moment they seemed like hard decisions, but in hindsight they were absolutely the right decisions. And one of those was we vertically integrated a lot of the core technologies. So all the electronics in the vehicle we design and build ourselves. The entirety of the software stack in the vehicle we built ourselves. The high voltage systems we built ourselves. And I remember this was in 2015, 16, I said to someone, it was if we do this really well, maybe a big car company will license this technology. And so last year we did a $5.8 billion software licensing deal for our base, what we call like software layer, and some of our zonal controllers, some of these, essentially the network architecture and the computers that run the network. And so that was amazing. But there's also areas where we decided at the start when we launched our first product that we would have to take more of a hybridized approach or approach where we leveraged third parties. And one of those, which was a recognized decision, was we launched in 2021 and we used a Mobileye-based self-driving platform, but with the intent to build our own. So starting at about that same time, right when we launched the car, we kicked off an internal effort to completely build a full in-house, both hardware stack in terms of perception and our compute platforms, but also like the whole data flywheel of how this would manifest.
Right.
And as everyone here recognizes, there's a really significant shift that happened, and we saw this playing out just in how autonomous systems were developed, where up until around 2021, these were very rules-based systems. In many cases, you'd have these collections of different pieces of perception you put together, fuse the signals fairly late, have some type of a rules-based planner that would be arbitrating between the different elements of the perception stack. But it was all very rules-based, and it was all very much, it wasn't really true, as we think about today, AI-based platforms. So you weren't using transformer-based encoding or any of the things we're doing now.
2021 is almost a really good time to start then. You weren't
so it was perfect because we had that was sort of the punchline, is we didn't have the challenge of a team that had built this big rules-based environment and a lot of infrastructure that have to get thrown away. And so we went about building a team where we owned the entirety of the perception stack, we owned the entirety of the compute platform, and designed it with the intent of it becoming this large data flywheel that would train a large parameter model offline that would ultimately run in a distilled version in the vehicle, on inference in the vehicle. And so that hardware architecture launched about a year ago, and we put that into what we now call our Gen 2 vehicles. And so there's not a single piece of shared content between the Gen 1 or Gen 2 on
It's a completely
Autonomy.
different hardware platform.
Different hardware, different software, much higher levels of compute. And we're now beginning to see the benefits of this really large data flywheel where we have any Gen 2 customer vehicle is part of feeding into the data pipeline that's building this offline model. And it's, we have the releases that you see on out in the road. If any of you own Gen 2s here, you'll see the features are getting better and better, but what's to come is giant leaps forward from what you're even experiencing today, but on that hardware through over-the-air updates. We did a 2-hour demo ride where we drove around essentially all of the Southern Peninsula, down in Palo Alto area, completely on its own. And that's what's coming. We call it universal hands-free.
Right.
We see, eyes off, hands off coming for, a large number of miles on the road, and of course, integration of that with route planning.
Yeah, it sounds like it's moving quickly.
It's so exciting, but it's really exciting to also just see how it's being developed and building this really robust data pipeline. Of course, spending a lot of money on GPUs.
Right.
But it's a totally different topology from what we would have had in 2021.
Yeah, that's super interesting. Something I'm curious about with Rivian specifically is that, you're talking earlier about your brand and your name and things, and the Rivian brand is, for me, so tied up with adventure. Every ad you see for Rivian is this off-roading, and even you guys had some vehicles at I don't know, CES or something in Vegas, and driving over some sand piles or something. Yeah. And so how do you mash that with autonomy, I guess? Did that affect how you thought about, I don't know, is autonomy for the less adventurous times of life, or are we going to have off-road autonomy too?
Yeah, I saw it driving in today. It's I think we all value our time a lot. So the beauty of autonomy, especially in a personally owned vehicle, which I think we're beginning to see. Here in the Bay Area, we see it every day. We're engulfed in it, but broadly, as you look across the trillions of miles being driven in the United States alone, it's just an opportunity to get your time back. So you get in the vehicle, you get in your car at the start of the day, you say where you're going to go, and the car takes care of all of that. That doesn't mean you don't also want to maybe go exploring or take your kids to the beach or hiking or off-roading, but just the ability to have your time come back is something we think is today a purchase consideration for maybe 25-30% of customers, but we really feel that within the next few years, this is going to become such an important decision criteria for purchasing a vehicle. Whether that's 2028 or 2029 is hard to say, but certainly by 2030, I think very high levels of autonomy in personally owned vehicles will become not a nice to have, but a must have. Yeah. And if you don't have that as a vehicle, your market share is going to drop very, very quickly.
Yeah, I mean, once you kind of
experience
start it, you get used to it.
It's hard
you can never go back.
Exactly.
Yeah, for sure. So you talked about building your own sort of whole hardware platform. A lot of the debate in self-driving has been a lot around vision-only systems versus multi-sensor systems. A lot of ink has been spilled over lidars, but we don't necessarily need to go there. But I'm curious, how do you think about pure camera only versus multi-sensors? What sensors you guys are incorporating?
This does get a lot of attention. I'm not sure why. In a vehicle, because of the complexity of the environment, it's inconceivable to have a vehicle without at least 360-degree view. And you can do that with cameras, but you're still dealing with multiple sensors coming together. So you have to build a model that's designed, or an approach that's designed around a really early fusion approach. Every signal, whether it's a camera, a radar, or LiDAR, is going to have noise. And the benefit of multiple modalities is, in an early fusion model, is just you can address that noise. You can actually design for that noise. And so I think historically, because of the cost of some of these sensors, in particular LiDAR, we saw bifurcation of level 1 or level 2 systems would be camera heavy, maybe camera plus radar, and the LiDAR would be really reserved for very expensive systems that were designed for robotaxi applications or vehicles which you're willing to spend, let's say, $10,000, $20,000, $30,000 on a driver, on a digital driver. Now, I mean, a LiDAR is a couple $100, and it provides a very helpful non-overlapping set of strengths with that of a camera. And so we find that that's helpful for both real-time decisioning that's happening in vehicle, for, let's say, object detection, which is particularly important. A core element of a vehicle that drives itself is it shouldn't run into things. And it's also really helpful for training the models. And so, if you think of training a model from an end-to-end perspective, much like we would learn to drive a car, you're learning to drive a car and you're having to learn to put your head a little bit on a swivel. You're turning your head often to say, is there a car over my right shoulder before I change lanes? And you're doing this because your limits biologically is you have two eyes that face forward. You have some peripheral, but you don't have eyes in the back of your head. So of course, step one is put eyes in the back of the head. So put cameras around the full periphery of the vehicle. And then next thing is, it's hard to drive in fog, or it's hard to drive in heavy rain because your visibility is more constrained. And these are areas where a radar is wonderfully helpful. And so we have found that the benefits of multiple modalities for perception are really helpful in training your cameras and training your camera models, but also really helpful for building a platform that has much higher levels of safety. Yeah,
that's an interesting point about using it for training.
Yeah,
I have a friend that says if humans could shoot lasers out of their eyes and get perfect depth estimations, they'd be much better drivers too. So
yeah, we also we find that our models just learn when you think about the difference of what was done pre-2021 to what's done today, because everything in this autonomous vehicle 1.0 phase was a rules-based environment, the systems were very sensitive to changing environments. So if you operate a vehicle in a different environment, it doesn't translate perfectly. Very sensitive to sensor placement and vehicle application. And when either of those things change, so if you had an enhanced set of sensors, it would require a tremendous amount of recalibration work. What we have found, not surprisingly, is that on a model that's much more of an end-to-end trained model, as you add enhanced perception, it's as if you take someone that learned to drive, if I learned to drive without glasses and you handed me a pair of glasses, I wouldn't forget all the things that I knew. My foundation model in my brain of how to drive wouldn't go away. It would just be enhanced with higher levels of precision. And so we're finding, like we're about to launch a new product we call R2. It's a much lower priced vehicle, but it's got a better sensor set than what's on our R1 vehicles today. It's running the same model. It's running the same, we call it the large driving model. So it's running our LDM, but it has more precise perception. Its capability to train faster because it can see things in ways, or perceive things, I should say, in ways that our current perception stack can't, is just accretive. It just makes the model better. And it's quite remarkable to see, as you add more perception modalities, how fast you can improve the learning speed.
So talking a bit about these kind of traditional methods, and obviously there's been this huge shift in the industry over the past few years, moving towards end-to-end systems. And we had Wave here earlier talking about their sort of fully end-to-end approach to driving. I'm curious how you think about that. Is the architecture just a single model and it's kind of some cameras in and some steering commands out, or how do you think about other layers that you need to incorporate there?
Yeah, I mean, I think there's two big open elements of this. One is how do you create some rules of the system so that the behaviors have some guardrails, and so things like speed or stop signs or lights. And so the way we've developed our system, we have this LDM, this large driving model, that is pure end to end. And so it's purely based upon us building models around our customer driving data. And of course, we put some ways to filter that, and we have specific triggers that we use to select which types of data we take. So if you were to drive across the median, we have a mini model that essentially identifies as very bad behaviors and plucks them out, so we don't train on that. But nonetheless, it is a result of training on humanistic driving because it is human drivers.
Right.
And so there are certain areas where humans bend the rules too often or do things that if you're an occupant of the vehicle you may not like or you may want to have as a setting. And so we have a few different ways we manage that with the way we tokenize the route trajectory. And then we have some loss mechanisms that we have in how we're training, and so the loss minimization framework takes into account some of these guardrails we're managing around.
So that's more more selecting data and going into the training more.
Correct,
so than sort of at runtime.
Yeah, and then there are some things we can do layering on top that's think of it as like a mini filter that decides, do we break some of these rules knowing what the rule is? But it's pretty lightweight. Most of the way we operate today is truly off of this LDM, this large model. The other big open question is how we build closed loop training. And so, a lot of, we all see it. We live here. If you drive down Page Mill, you see Rivians with extra sensors. You see Teslas with extra sensors. Effectively, you're seeing, engineering teams do open loop testing of the model. That's comes out. We run a model on an 8x8 cluster or whatever, and it's okay, the model's improved. Let's go test it. And you see that testing. Some of that happens in customer cars as well, where you look at some performance metrics and heuristics, but we're now actively looking at how do you actually simulate the performance of the model in a closed loop way, so it's part of the whole training loop. And then of course the big obvious question is how you do that in latent space so you don't spend as much energy or time or effort creating visualizations that are helpful for humans but not necessarily necessary for the model training. And I think there's some big open questions on how that's done. Clearly everyone is still using a lot of open loop validation.
Right.
Us included.
I'm curious, what are some of the bad behaviors you noticed from just training on too much customer data?
So there's some fun ones. So our cars, our Rivians they accelerate very quickly, and we have something we call launch mode, which you can put the car in a certain mode and it stomp the pedal and accelerates really quickly. And so the emergent behaviors are always funny to see what ends up tracking in. And so on certain roads where there's a long straightaway, we were noticing the car would always want to accelerate faster than in roads that didn't have a long straightaway. And what it was is 20% of our drivers, when they have a they're the first car at a light with a straight section with no lights between,
Just floor it.
they would floor it. And so that became this strange emergent behavior, and the team was like chuckling, like, you find the cars in self-drive mode is stopped at a light with a straightaway, it likes to accelerate. And so it's just, it's behaving as it's been taught by our customers. So those are the types of things that we have to manage to create a driving experience that doesn't directly replicate the humanistic behavior.
Yeah, no, I don't want to be too human with your driving.
Yeah. So we have, that gets into how we manage, like we have, like internally we'll talk about like drive like your grandparent mode, but there's ways to like set your driving style. Do you want it to drive?
Will that be a setting, grandparent mode?
Yeah, so like very slow response, like not switching lanes often, and then somebody who's more like of a New York driver that's aggressive, and we want to give customers a choice of how they want the vehicle to behave.
And so that's something that would be part of that's sort of happening at inference time. That's just part of the prompt going.
Yeah. And then we also have an interesting model we're building where we learn you as a driver, and we say we can actually replicate your specific driving style. And so that's something that will come as well.
Yeah.
So there's like you could say like aggressive or calm, or do we want us to observe you, your user profile, and then start to replicate your style?
Hit the gas at all the straight roads. Yeah. Nice. So we talked a bit about data and talked a bit about sort of customer data. Something that I think we've noticed as driving has moved to these end-to-end approaches is that we need a lot of data to train on. And of course, a lot of the robotics companies here, a lot of the big talk in robotics outside of self-driving is like, where are we going to get all the data from to train robot models? You guys are in a fantastic position to have this big fleet of vehicles, but I can imagine that there would be some challenges around how do you can't just upload all of the data from every drive that every customer has done. So how do you kind of think about sampling across that? How do you look for interesting events? And I guess bandwidth too is probably a concern. I don't know if you have to upload over, is that sort of 4G, 5G, or customer Wi-Fi? Yeah,
it's a great question. I do think this is missed. It's like so often overlooked, the complexities of moving a lot of data.
Right.
And so we have, fortunately, we have a bunch of other services that are not related to autonomy that benefit from having Wi-Fi. And so we have the vast majority of our vehicles are Wi-Fi connected. And we have a whole host of reasons you'd want to do that, which your over-the-air updates. We do a monthly over-the-air update. It's faster. The economics of that are better if you're on Wi-Fi. And so we have the vast majority of vehicles are on Wi-Fi. So that makes it easy. So we can do an upload every night when or whenever the vehicle reconnects to Wi-Fi, which generally is every night because it's usually in people's house in the garage.
Everyone wonders why their internet goes slow after midnight.
Yeah. So that's the first thing. The next thing is, what do you send up? And there's obvious triggers, like when you have an event, a disengagement, that's interesting data. But we've, because of how we're building our models, we actually have, at all times when you're driving the vehicle, we're also running in parallel our model and therefore generating our preferred trajectory. And actually very interesting is when you do something different than what our model is predicting you would do. And those are all great learning opportunities. So if our trajectory says you should change lanes now and you decide to not change lanes, or you decide to change lanes on the other side, those are reasons for us to like dig in and use that as some of our training data. And that, back to your point, that's also a lot of the thought goes into what do we then filter for, in terms of, like, we run this mini model to decide what is used to train the big model. But like, you're talking many thousands of use cases that are happening every few minutes. So there's a lot of data that's coming in, and you can spend a lot of money really quickly running wasteful experiments. So we've tried to be really thoughtful on the types of experiments we're running, the types of data that we're using, and we're getting better and better at it, which we're going to see in the products. Yeah, even then, I mean, just storing all of that data would start taking up a massive amount of space. I say this all the time, it's by far our biggest spend category as a business. And so we have a huge R&D budget, but this is where we're focusing the most significant portion of our R&D. Yeah, awesome.
Great. So I think this year you guys announced that there's sort of a, I think you said you came out with Hands Off recently, or that's coming soon,
Yep.
and then possibly Eyes Off in 2026. What have we got to look forward to in the Autonomy?
Yeah, so we have this Autonomy Day that we announced that's going to happen in December, and in that, it's like building any business. You're building a business. You're doing a bunch of things that the world doesn't see yet. So this is our chance to pull the curtains back and say, here's the hardware stack that we're building. This is how, there's a lot of stuff that we've developed that we haven't yet talked about externally. So here's all the stuff. Here's when we talk about data flywheels, actually, how does that work? What does that look like? And just give some scale to this, because I do think, to your point, Rivian is a small fleet relative to, let's say, an incumbent car company. But the incumbent car companies don't actually have a way to either capture the data,
upload all of that data, yeah,
or upload it. Do they even control? If you're using let's say a Mobileye front camera, none of that data is available to you to train off of. And so we're really bullish on what we built in terms of that type pipeline. We're going to show that, and then of course, it wouldn't be a day like this without a proper demo. So we'll demonstrate how this works. And what that does is it gives essentially a sneak peek for what's going to be showing up in customer cars fairly soon. So that's hands-free everywhere. We call it universal hands-free. Then moving hands-free, eyes off in certain environments, particularly highway, which is really important for getting your time back. And then all of that overlaid with route planning so that you can put your address in, the car will take you there. And depending on the conditions, you may have to be somewhat involved as a redundant layer, but over the fullness of time, the goal is to have you not involved at all. And I think, it's sort of cool. We're living right now in a moment, I have a 9, a 7, and a 6-year-old. We're part of a generation that's going to see this world where we have this dynamic of the human still has a role to play in supporting these AI systems becoming better. But it's not far from now where it will just become expected that you get in the car and it will truly fully drive itself. And I'm quite bullish on that being, within the next, this is the next 5 years. This isn't 20 years from now.
Kids might not need a license.
Yeah, so my kids, it's very realistic that my kids will hop in the car in the garage and just go places and not need to drive the car. And so that's, whether that's 2030 or 2031 or 2029, that's, I think, the big question of when can we completely and start to fully remove the human redundant layer, which for those of you that are driving, let's say a Rivian or a Tesla, we know that you have to be in the driver's seat, you have to be awake, you need to be looking at the road occasionally, these sorts of things, that the role of this redundancy will just start to diminish over time.
Yeah, awesome. So that was very interesting to hear about the autonomy side of things. Another area that is obviously very big in robotics is manufacturing.
Yeah.
And you obviously are scaling up manufacturing, I think now, and probably even more so than incumbent auto manufacturers. You have a chance to sort of be designing new manufacturing lines in 2025. So how do you think about robotics in the manufacturing side of Rivian?
That is a wonderful question. We have, so we produce all of our vehicles, say, in one plant. We build this flagship set of products. It's the R1, so there's an R1T and R1S is what we see around here. Then we also build commercial vans. Amazon's the largest customer of our commercial vans. It's actually the largest electric commercial fleet in the world that Amazon's running today with our vehicles. But still, with all of that, it's been relatively low volume. And so our first high volume, what we would call mass market product, is this R2, and then it has a sibling product, which we call R3. It's a mid-size SUV and a mid-size crossover. And in both cases, that significantly steps up the amount of volume we have as a business. Not too different from what happened with Tesla with Model 3 and Model Y, really bringing scale to Tesla, just by virtue of the price point needing to be in that $40,000 to $50,000 range to attract, a huge portion of consumer demand. And so those products launch next year. And the exciting thing is we're building the first plant for that as we speak. It's going to be launching here, and we're going to start building out of it here very soon. But then there's a whole string of new plants we have to go build. And so we just broke ground by coincidence last week on a plant that we're building in Georgia. It's a huge facility, 2,000-acre site. There's future plants beyond that as well that will be building these future products. And because there's no infrastructure, we have this very big question of how do we invest in infrastructure where the dollar sizes are huge? So like a vehicle plant is a multi-billion-dollar investment that you would want to amortize over 10 to 15 years. So these are not things you want to sort of invest in the wrong tech. And so we're absolutely rethinking what is the layout of the plant, what does the plant look like through the lens of much more advanced robotics. And to state the obvious, today our existing plant, we have over 2,000 robots in the plant. And you'd walk in and you say, oh, it looks cool, there's a lot of robots. There's, they're big 5-axis robots, they're high degrees of articulation. But these are not AI-based robots. These are like PLC controlled, very, it's very old tech. It's like they actuate, they look cool, and they're doing things, but there's no real-time reasoning. The dexterity levels are relatively low, and they're doing highly, perfectly repeatable tasks of, let's say, putting a body together. So the metal bodies for our vehicles are built in an entirely automated line, but without the use of AI. And so the obvious probing question to ask is, there's still thousands of people in the plant that are doing other things, and why don't you have robots doing those things? And the answer is, the things that we have people doing require high levels of reasoning, high levels of dexterity, are not perfectly repeatable, and therefore would really benefit from AI-enabled robotics. And so that's a topic, we haven't said anything publicly on this, but it's something that we're certainly spending a lot of time thinking about. And I do think manufacturing and rebuilding industrial capabilities here in the United States is going to benefit greatly from high dexterity, high reasoning capability robotics moving into manufacturing, which helps provide some equilibrium on cost structure with countries that have long benefited from much lower labor cost structures.
Right. And you're sort of looking at developing that AI in-house, I guess, as well.
There's lots. You guys are all here. There's lots of people working on some of these topics. So there's an interesting question of there's existing legacy companies that have built robotics for industrial applications for years that have strong mechatronic capabilities for, call it highly repeatable but low dexterity movements in 5 axes. You have, but with no AI, and for that matter, we talk about AI and some of these things. We're not even doing GitHub repositories for the code. It's on the device. PLCs, very, very 1980s style software for that type of robotics control. So the question is, can they become more AI enabled? Probably not. And then there's new companies that don't have industrial experience or scale, but have AI experts that understand how to build modern architectures, or even architectures that are beyond current state of the art, but haven't run large industrial businesses to create industrial pipelines to build all these robotics. And then we're in the mix of this where we've learned, in some cases quite painfully, how to run and manage large supply chains, how to run an industrial company, and we're directly seeing the lack of product that exists. For us to design plants or processes that use high levels of AI.
Yeah, it's really interesting what you said about you're making this huge capital investment today, but you don't necessarily know where robotics is shifting so rapidly. You need to really be.
And I mean, it's true for the entire value chain. So robotics is the visual manifestation of AI that we think about in a plant, but think about how the plant is run. So think about material movement, people movement, process design, just the whole orchestration of how the plant is running is still very human-centric. And for those that haven't been in a large-scale, highly complex manufacturing plant, it is like a city. It's buzzing. You've got people movement. You've got lots of logistics happening. So there's parts constantly moving to feed line side. And you look at it and you immediately think to yourself, boy, if we had infinite knowledge, if you could make better decisions across every single step of what's happening here, you could take out enormous amounts of waste.
Yeah.
And so classically, things like lean manufacturing would try to do that through high degrees of coordination, like lots of standard process.
Rules-based system.
Yeah, but you can also look at it and say, well, if you could insert like an orchestration layer that led to much better decisions happening across the entirety of the operation. So predicting when material levels were low, predicting if you had a machine down, responding to that. These are all like helpful things I think are just going to change the way a plant is run.
Yeah. You said you had a couple thousand robots today. What would the ratio of sort of robots to people be in one of your plants?
Well, today we have a plant in Illinois. We have about 4,000 people that work out of the facility as well. So
it's pretty high.
Yeah, it's a lot of people.
Yeah,
it's a lot of people.
A lot of robots.
So if we're going to build more production capacity, if we're going to grow from, the scale we are today to many millions of units of capacity and products we're building, there's tens of billions of dollars of capex that need to be decided as to how they're going to get deployed. Do we deploy those tens of billions of dollars of capital towards plants that look like essentially the way they've looked for the last 20 to 30 years? Or do we deploy them into something that's going to look a lot more like the next 20 to 30 years? And the answer is obvious, but what the intent should be, but the solutions have to be created.
So for folks in the audience that are thinking about starting a robotics company, what do you wish someone would focus on automating for you? What are some hard unsolved problems in manufacturing?
I think that I'll make a more general statement. If you're thinking about robotic applications, we in the room all have experience in our daily lives. So we all deal with some version of having to wash dishes and fold laundry. And so I think it's easy to look at those as environments where you'd want to automate with robotics. But those environments tend to be fairly open. They tend to be less controlled, and there's not clear economics as to how do you monetize that. If you contrast that with industrial applications, they're highly controlled environments. They have enough variability that we still have lots of human operators running those environments, but there's very, very clear opportunities for ROI. And the decision makers on designing these layouts or these plants have like very clearly defined financial metrics that they'd like to achieve. Like Rivian is an example of one of those. And so I think there's been because of lack of exposure to complex manufacturing, I think there's way more opportunity in the industrialized space than the world has fully appreciated or recognized. And I say this because I have the benefit of like lived in a plant for years. And so I walk in and it's just like, holy cow, there's 100 companies that could exist to make this run differently. But I think a lot of folks that work very heavily in AI just haven't had the benefit of spending 6 months on the plant floor to just see these opportunities, which are they're big, giant chunks of low-lying fruit. And the companies that build the equipment or the processes or the tools that run in those environments tend to be legacy businesses that are running off the momentum of the past and not generating like true first principles thoughts on how to redefine the architecture. So I guess my advice would be make sure you're look at the broadest spectrum of opportunities to build businesses and apply your technologies. But I do think industrial is a huge space. If you look at the U.S. economy, truly half of the cost of running our economy is in labor.
Yeah.
And so it's just a giant opportunity. So movement of stuff, movement of inventory, installation of stuff, installing wiring harnesses or carpet sets or lacing a shoe. I mean, these are all you're seeing huge opportunities there, and I think there's been an under focus on that today.
Awesome, Ajay, Scaringe, thank you very much for joining me.
Yeah, thanks.